In this video, we're going to be implementing the genetic algorithm. As always, I already designed a UML diagram or class diagram for you, so let's quickly revise the classes that I'm planning to design and code in this video, and then we'll start creating a project in the Eclipse IDE. So there will be 5 main classes in the genetic algorithms. The main one, the first one that we're going to start with is called chromosome. Remember, chromosome is basically a solution in the genetic algorithm that is made of multiple genes, right? So that's exactly why I have an array of type object and the name is genes, right? So you can make it integer, boolean, or character depending on your problem, but I always make it of type object so you can put everything inside it. So it's up to you. If you only work with integers or 0 or 1, if it's a binary genetic algorithm, then you can make it Boolean or even integer. Fitness, every chromosome has a set of genes, and at the same time it has a fitness value. Also, I've got gene numbers. Sometimes you can easily get the number of genes as well, although you can say genes.length, but I decided to put it as one of the private members. I've got two constructors, one to create the chromosome. It's an integer between, it's a constructor with one input of type integer. This is a default constructor. Initialize, that's going to initialize this vector or this array. Get single gene, that's going to return ith gene, where I is the input of this function. Set single gene, that is where we mutate a gene. I will use it in mutation. Get fitness, set fitness, get gene number, get genes as well. So these are some getters and setters. Once we finish chromosomes, then we will start working on population. What is a population? Population, let me just maximize this. Population is made of multiple chromosomes. That's why I have here a list of chromosomes of type this class. It is a private member, and of course, these classes are highly related. A bunch of methods, population, initialize, that's a constructor by the way, initialize, get fittest, that's where you can get the fittest, the best individual in the population, get chromosomes, get single chromosome, and add to the population. So that is how you can add something to the population. So basically the idea is to create a population if you want to initialize it, if you want to get the best one, or if you want to add something to create a new population. When we finish these 2 classes, the next step is to work with genetic algorithm. So we've got population size. These are some controlling parameters for the genetic algorithm. We talked about it before. Population size, gene number, maximum number of generation, tournament size, if you want to use tournament selection. If you want to use roulette wheel or something else, you don't need this. Crossover rate, mutation rate, very important parameters. Elitism, Boolean, true or false, and display the result if you want to see the result. And I've got the main functions here. That's a constructor, doesn't matter. Tournament selection, crossover, mutation, elitism. So I have literally 4 functions for the main operators or the main steps of the genetic algorithm. Every optimization technique or algorithm meta-heuristic requires a fitness function. So that's where it's not fitness functure, it's fitness function, it's off. I don't know why. Sometimes it does that when you generate it automatically. Anyway, so I decided to make it static class, but it doesn't have to be static class. You can make it dynamic too, so you can instantiate it, but I thought it's a bit easier. My fitness function is to just find the minimum. Basically, it's just the summation of all the genes. So that means the best solution is where all the genes are equal to 0. So we'll see how genetic algorithm mutate, combine, or cross over the genes and chromosomes to find all the genes equal to 0. And then once we finish everything, we'll start working on test.g.java, which is where we create genetic algorithm and gene and apply it to the problem. So without further ado, let's open a new project and name it Java. So I'm naming it genetic algorithm, so genetic algorithm. There we go. I'm going to create a package, new package, genetic algorithm, if I spell it right. And then I can create all classes. I'm going to create all of them. Chromosome, chromosome. First one, in a file, new class, population, without a space, of course. The next class was GA. Was it GA or genetic algorithm? Let's double check. It is genetic algorithm, test GA, and fitness function. So right click, new class, genetic algorithm, right click, new class, fitness function or heuristic function, and then right click, new class, test GA. Perfect. So we'll start with the chromosome, as I said before. Okay, so there were three members, private object, genes, private, double, fitness values, private, integer, gene numbers. And now we can work on the constructors. So from public chromosome, make it a bit smaller, by the way, and get rid of this project explorer. We don't need it. There we go. So public chromosome, that's the default constructor. So I would say this, the genes equals to new object. This, hang on, this should be brackets because it's an array. So why it keeps going up there? There we go. New objects, this dot gene numbers. But if you wonder where gene number is, that's where the other constructor comes in. So public chromosome, integer, gene numbers. So we first start it, and then if you want to create a new chromosome, we use that as well. Okay, so this the gene number, if I can, this the gene number is equal to gene number. Perfect, all good so far. There is no error. I don't know why I wrote the brackets. Okay, now these are the methods, the main methods. One of them is initialize, so public void initialize with a variable of type double. We will see what that is. There we go. Again, remember there were a bunch of this. Before I write the rest of the function, let me implement them one by one. So in this function, I'm going to write a for loop, go through all the genes. If a random number is less than this probability values, we assign 0, if otherwise 1. So if you want to initialize all genes with 0, then p is equal to 0. All genes with 1, 1. Any a number between them, you assign a probability. So here's what I mean. For int I is equal to 0, I is less than.
Welcome. Please select the files you want to use today from this window.
Why this file opens up? No, okay, so we'll continue. So I is less than this the gene number, and of course I plus plus. And I would say if math.random, this is going to give me a random number. Why it doesn't recognize math? Math.random is less than p, then this the genes, the gene number, this the genes, if I can find it, I is equal to 0. Otherwise, or else, this the genes, I is equal to 1 as well. So it's just initialization. And remember, whenever you initialize something, you have to also calculate the objective value. for each of the chromosomes. So that's where I have to create the objective function because I need it. Otherwise, we don't know how good the solutions are. So I didn't want to start it now, but I have to because I need to calculate the fitness values. So again, I say this is a static class. So public, it's not a static class, it's a class with static members. Public static double evaluate. We're going to pass objects or genes of type objects. And then here double sum is equal to 0 for object G inside the genes, sum plus equals to G, or double, I can write it, G. And then we just need to return sum. There we go. So the fitness function is done. So that is where you can calculate your fitness function. So let me just write a comment. This is fitness function. Now I can add it. I can go ahead back to the chromosome and say, okay, if I click here, this dot fitness, in this as a part of the loop, by the way, it must be a part of the loop. There we go. This dot fitness equals to, hang on, fitness function dot evaluate this dot genes. So we pass the genes to this function. It will calculate the fitness value. We assign it to this variable up here. And there is no warning anymore. We use it. But why is the value of this field is not used? Yeah, I use it at some point, but I use it here. Is it? Hang on. Anyway, we'll see if this causes any other error. For now, I don't see any error. So now the rest of this function, this file, is to write a bunch of getters and setters. I cannot use that automatic generator because I need to have customized getters and setters. One of them was get the ith gene. So public get single gene, integer I, return, if I can spell it, this dot genes, not gene number, this dot genes I. There we go. Now this is the void, of course. This is a procedure, so void. And then next one is public. Hang on, this needs to return something. So what's the type of object? So yeah, my mistake. There we go. Public void set single gene. By the way, this is not going to return an array. It's going to return just an object. Public single gene int I. And now here I would say this dot gene. Hang on, I need to say, okay, assign to this gene number this object. I need two inputs given the fact that I designed it before. So I would say this dot gene, this dot genes I equals to O. Okay, and the other ones are, let's say, public void set fitness, set fitness double fitness value, just in case you wanted to update the fitness value of this file or the chromosome. This dot fitness, not fitness, fitness equals to fitness 2. And given the fact that I have this function, I can easily call it here. Instead of saying this dot fitness equals to this, I would say this dot set fitness, and then I add this as the inputs. Okay, I think it's a better practice because I've got this function for this purpose. And the other ones are set get genes and get all the genes. So get a public integer get gene numbers. It's going to return this the gene number, of course. There we go. And finally, the last one is public object get genes, and that is where we're going to return this the genes. Okay. All right. So everything is fine, and I don't see any other issue with this file. We should be able to even compile it. There is no main, but it works. There is no error at this stage. The next step is to work with population, which is over here. So in the population, we have a bunch of chromosomes, right? So that is the first step. So I would say private chromosome with chromosomes. If I spell it right, there we go. Let's start with the constructor. Integer chromosome number, integer gene number. So that is where I need to create a bunch of chromosomes. Oh, it's easy. I'm going to first instantiate this. Chromosomes is equal to new chromosomes. Hang on, I do not need to write this twice. So gene number. Chromosome number, sorry. This is the number of chromosomes. Public, by the way, chromosomes. So that's going to create my list of genes, or my list of chromosomes, I should say. Why it keeps showing me this error? Set method return type void. But it is a constructor, doesn't matter. Oh, hang on, it's population. My mistake. Yeah, that's why. There we go. Population. And then in a for loop, I would say for int I is equal to 0, I is less than chromosome number, and I plus plus. Okay, there we go. So here's, I would say, chromosomes. So this is going to create an array of chromosomes, but now each of the chromosomes in an array should be instantiated as well. So chromosome I is equal to new chromosome with this number of genes. There we go. So we'll make a bunch of chromosomes here. Then we instantiate them one by one. This should be, by the way, chromosomes. Is it gone? Yeah, there it is gone. Perfect. Okay, so now we're going to initialize the population by saying public void initialize double p. And all I need to do is to write the for loop for int I is equal to 0. I is less than this dot chromosomes dot length. I don't want to pass gene number and chromosome number anymore. Dot. It says unreachable. Interesting. So why? Oh yeah, because there is no this. Dot length. Perfect. And I plus plus. Here, I would say chromosome I, just like here, dot initialize. Probability of p. That's it. So I'm calling this function initialize in my chromosomes. So all done. I've done constructor and the initialization so far. One more function, get fetus, so public chromosome, that's going to return a chromosome. Get fetus. I'm going to create a variable called min, which is going to be initialized with the maximum double. So double.max value. chromosome. In case of minimization, if you want to minimize a fitness function maximization, you can either multiply by -1 to get a minimization problem, or to convert it to a minimization problem, or you can change this to max. Chromosome best chrom equals to null. We're going to update it at some point. Now for the same for loop up here. Now in this for loop, I'm going to check and see whether, the current chromosome in the list is less than the minimum, and update it if that was the case. So if this dot chromosomes I dot get, hang on, I have to write this if this dot chromosomes I dot get fitness. Okay, so it doesn't give me the fitness value of a chromosome. Did I have any function called get fitness? Oh, I don't have it, so let's go and define it then. Public, because I need to get the fitness of a chromosome, public double get fitness, return this dot fitness. I need that. So head back to the population. Here I would say if this dot chromosome dot get fitness is less than the minimum, then minimum is equal to the fitness, and also the best chromosome is equal to this dot chromosome I. There we go. And at the end of this function, we have to return over here, we have to return this dot best chrom. Not this dot best, just best chrom. I think I have it in my clipboard. No, okay, so I'll just copy it from here. So this dot best chrom. All done. Now a couple more functions, maybe 3-4 functions left. So public, one of them is to return all the chromosomes. So public chromosome array get chromosomes. Don't mind the spelling errors and stuff like that. It works just fine. This dot chromosomes. It's going to return all the chromosomes. The second last with last function, we'll see if we need something else. Public chromosome, let's say what if you want to get a single chromosome? This will get all of them, but what if you want one? So I would say get single chromosome index I. That's going to return this dot chromosome I. And remember, in our, let me see how many so far. So I've got one constructor, 1, 2, 3, 4. In our UML diagram, we have population 1, 2, 3, 4, 5, 6. Yeah, add int chromosome. So I need to include that as well. Should be this, by the way. So I would say public void add integer I and chromosome I. Chromosome C, let's say. All I need to do is to say this dot chromosomes I is equal to C, and then we have to also calculate its fitness value. Why it keeps showing me this error? Every time we add a chromosome to the population, we need to calculate its objective value, or if its fitness value. C.set fitness function dot evaluate C dot get genes. There we go. There is no error. See, I can compile these two. There is no error. And there are two classes left, which we'll do in the next video. This video is getting already very long. So let me quickly summarize everything. In this video, we started with chromosome.java. A chromosome is made of a set of genes, fitness values. We also had to include gene numbers. It's optional. You can exclude them. A bunch of functions to initialize, get single gene, set single gene, get fitness, set fitness, and stuff like that. Then with that chromosome, as a part of the chromosome, we would have to calculate the fitness value. So I had to implement fitness function as well. When we finished those two files, we started working on population. In a population, we have one list of chromosomes. The constructor initialize, get fitness, get chromosomes, get single chromosomes, and add a given chromosome or a given chromosome to the population. In the next video, we'll create a class called genetic algorithm. We'll use chromosome and population to create a population of random chromosomes with random genes, of course. Combine them, mutate, select the best ones, combine them, mutate them, keep some of the best ones for the elitism, and we'll see how we can minimize this objective function that we already designed.